Feel like July when we look what's going on in the tropics, but it is. It doesn't feel like July when you step outside here at South Padre Island, where I am today, where the dew point, I don't know, feels like it's about 90. It's not, but it feels like it. Super warm, super humid out there. Glad to have you along today. We're here because of our sponsors who make this a possibility. USAA. Thank you, USAA. We appreciate everything you do for NTWC, for the Storm Science Network, and all the projects we do. USA, a strong supporter from the very beginning. The South Padre Island Convention and Visitors Bureau, we are here in person every year, first week of April, for the National Tropical Weather Conference, and South Padre Island Convention and Visitors Bureau makes that a possibility, as they're a big help and a big supporter. We appreciate them as well. Weather Boy, the Weather Company, Weather Call, all supporters of this program. And what a program is going to be today. Timing could not be a whole lot better. Brian McNoldy is with us, and we're going to get to Brian in just a little bit. Dr. Hal Needham is here. Good morning, Dr. Hal. How are you this morning?
Morning, Tim. Doing great. Hot weather and hot water up here. The water's been 91 degrees the last several afternoons here in Galveston.
Oh, pleasant. Go for a warm up in the dip. It's a hot tub, right? Good to have you along, Hal. And Bill Reed, former director of the National Hurricane Center, is with us this morning. And Bill, let's get right to it. Usually we put our tropical update a little bit later in the show, but today, obviously, there's a lot to talk about. So let's get to that, and then we'll get Hal, and we'll get Brian McNoldy on in just a minute. Good morning, Bill.
Good morning. Yeah, it's a good thing we do it early. The data changes by the 5-minute period. So if I waited to the end or the middle of the show, it'd be already stuff people knew. Okay, let me share the screen here, and I'll get right to it. The new advisory is in, and fortunately they popped the graphic up in time to get it in the slide set in here, and really not a whole lot of changes have occurred in the situation with Beryl. It's still a formidable 145 mile an hour major hurricane. It's still moving along, maybe a skosh slower than it was the last 2 days. And further slowdowns are expected as it comes around to the west side of the Azores Bermuda High. The big issue is big show today is Jamaica. We'll get into detail on that in a minute. It looks like the core of the eye itself is going to be just offshore. It remains to be seen exactly how much of the eye wall winds get into the coastal Jamaica, but at least at this time, it doesn't look like a repeat of Gilbert, where we'll be stripping the trees off the mountains by going right down the mountain chain. Then it'll traverse this evening, do a closest point of approach to Grand Cayman tonight. And unless there's something radically change on the system, I don't think we'll see the really big winds in Grand Cayman, but they certainly will have big seas hitting their south shores and east shores there. After that, it's a run across the northwest Caribbean for a landfall in the Yucatan Peninsula. Right now, the areas most at risk for the core are from Chetumal up through Cozumel, Cancun. And then where Tim and Hal and Bill get interested in this storm is what it does after that. Consistent with last night's forecast, they're still forecasting a more northwest track and regain hurricane strength prior to making landfall somewhere in northeast Mexico to South Texas. The water vapor imagery today, if you read the discussions from the hurricane specialists, we're encountering some shear now. Boy, I hate that text that comes up in that. But you can see, if you follow the cloud elements, a westerly wind out here in advance of the storm. We talked a little bit about it offline beforehand. The core is held together. The winds have held together on that. I don't think this modest shear yet has reached the small core of this storm. It doesn't look like it in the recon data. So unfortunately, we don't see any weakening for the impacts on Jamaica in that. Closer in. This morning's visual. Courtesy of Weather Nerds. I like it. It pops some lightning in there. And again, the core looks pretty intact in here to me. We've lost the clear eye, obviously, but it's not far. We should be feeling the impacts very shortly of the core winds in the Kingston area in Jamaica. And Brian McNoldy pulls together these great radar loops, and he managed to get clearance, I guess, to get into Cuba's radar. Actually, you can get into it if you want. But this is a long-range loop that he's made of the of the Cuban radar over here, and you can start to see the outer rain bands have come across Jamaica, eastern Jamaica now, and there's the eye. And it does appear on the radar, at least, also that the eye wall itself is going to be just offshore as it passes by. The recon is valuable as always, and that, given the satellite appearance on it, we think we would have had if we had no recon in there, we would have had lesser winds forecast, lesser intensity based on the satellite, and the Dvorak estimates bear that out. But obviously, the storm thinks otherwise. It's holding together quite nice. Not any significant change in pressure since the aircraft's been in there. Get down here. Yeah, these are the graphs that show the passages through the eye and the eye wall in there with the major wind speeds being reported there, 130 at flight level and about 110 on this pass, and still a very warm core. This is the flight level temperature of plus 20, where typically in the tropics this year would be plus 8 to 10. Oh yeah, one more thing on the thing. I don't know how many of you look at the dropsondes. Oh, got the wrong one. Operator error. Come on, go back. Here we go. Northwest eye wall. There we go. Note how strong the winds are down low in the dropson there. That some of that, if it got up in the mountains, that's the kind of winds that'll strip the trees right down to the ground. You know, those are the major strong tornado strength winds in there, and they're not reaching the surface usually. And there's probably something, some of the winds we saw in Otis last year that resemble that. So lots of great data coming from the plains. The basic spaghetti plots have the primary solution is where the forecast is going, and just south of Brownsville. Tim should get some good video of the waves coming in this weekend on South Padre. But there are a couple of solutions that keep the storm stronger and bend it further north into Texas, and that'll keep us on edge. We're very confident through the landfall in the Yucatan, and then so it'll be a couple days before we probably get model certainty on what's going on downstream from that. Just wanted to run through. This is the GFS from 06Z, the 850 vorticity, 500 millibar heights, and 200 millibar winds. Give you a snapshot. Look, the strong ridge is searing it west, at least in the initial part, is a given. That's not a big surprise. This leading upper level trough moving out ahead of it, and then this trough in the westerlies, it's in the central plains come Friday, is the culprit that'll start nudging it into a more northwest track, if in fact it does reach the influence that far south. The combination of this upper level to low leading the hurricane and that trough are key players on that. And I think if this actually verifies that the shear weakens considerably, and I think that's why the Hurricane Center is opting to bring it back up to a hurricane as it crosses towards Texas. And then here's the big question mark will be on Sunday is the weakness in the ridge and the entering trough in the plains going to be strong enough to lift it northward, or will that trough get out of the way and leave it behind? And the GFS run of last night brings it in and then dies it, almost reminiscent of Harvey. This is where you get big rains, is when these get stuck between the two ridges. And this is 96 L, which nobody's impressed with yet, and neither is the model until beyond the forecast period. But that would be really interesting. We still have Beryl going on and have something else come inland on us. What else did I want to show? Oh yeah, in excess of 10 inches in places, if in fact that's what was to occur. H-Wharf on Beryl here. Where are we? Go. This looks like the H-wharf brings some of the core winds along the coast of Jamaica, which would be really catastrophic in this case. And we'll get one more. And the HAFS A does the same thing. The southernmost coast of Jamaica, if these models are absolutely correct, are going to bear some of the north eye wall as this storm goes by. The ensembles from the European, the stronger storm gets to the right of the mean tracks. They come up as far as the Sabine River in the ensemble runs, with the secondary and most prominent conclusion, a weaker storm going where it's forecast to go. The GFS not so much with the stronger solutions. 96 L for those that are interested. Both models don't lose it. There's still some members that keep it as a potential storm as it gets into the Gulf of Mexico. That'll be next week's problem. For now, there's the outlook, 20%. And there's the outlook in the East Pacific. I didn't even look at that there, but it's a 50%, not a factor to land as far as I could tell. With that, I'm going to turn it over to Hal and introduce our guest, and we'll get on with the show, unless you have some questions, guys.
Bill, thanks so much for a great tropical weather update there. A lot to look at and consider this morning. Well, y'all, you're going to love today's guest. Brian McNoldy was born and raised in Reading, Pennsylvania, and has had a general interest in science since childhood. His passion for weather was sparked at age 7 by a big nor'easter snowstorm of February 1983, and then further peaked by Hurricane Gloria in September of 1985. He earned his BA in physics and astronomy from Lycoming College and a master's in science and atmospheric science at Colorado State University. He spent the next 10 years working at Colorado State University's Department of Atmospheric Science, conducting research on a variety of topics, specializing in tropical cyclones. Brian is currently a senior research associate at the University of Miami Rosenschul's School of Marine, Atmospheric, and Earth Science. Brian, thank you so much for joining us today on NTWC Plus.
My pleasure, Hal and gang. This is always a great time here to talk hurricanes and action in the tropics and all that. So yeah, I'm really happy to be back.
Brian, you've been in Miami for a long time. I've seen some even local newspaper articles just talking about how your expertise has helped people obviously around the country and around the world, but even folks there in South Florida think better about hurricane impacts.
Yeah, I guess I'm doing okay with it, with some of that stuff. So yeah, I've been here, I guess, about 12 and a half years or so, and it's been, I mean, this is definitely the place to be if you want to live, eat, and sleep hurricanes.
Brian, you've done a lot on social media this season, just talking about the record warm water temps out there in different portions of the Atlantic Basin. Can you walk us through that a little bit? I mean, what do these records look like? Where are we seeing these record temperatures, and how does that impact hurricanes?
Yeah, this has really been a topic of just amazement, I think, for anybody looking at it. Last spring, we started to see ocean temperatures in the tropical Atlantic just escape the norm. They became record-breaking in May or so, and that has not ended. So all the rest of 2023 was all record warm, and in 2024 picked up where that left off, of course, and it's now breaking the records just set in 2023. So the tropical Atlantic, both in terms of sea surface temperature and the more robust quantity of ocean heat content, are all not, I mean, to say it's record breaking is an understatement. They don't look like any other years used to.
So say the water temperatures in the Western Caribbean now, what are they? Are they, I would imagine, more indicative of August, September, or is it even beyond what we see in those months?
It is beyond that. For sea surface temperature, the Caribbean is warmer than it normally would be at its peak. And it's only the first week of July.
Wow, just absolutely incredible. Bill, you want to jump in there? I know you look a lot at sea surface temperatures. You're often showing these oceanic heat content maps. I mean, what are some questions you have for Brian on this?
Yeah, the the climate change connection gets kind of fuzzy because at least what I've read, this is way above what we would expect solely from the trend in global warming on that. And another thing, I think it's a factor, and you can correct me if I'm out to lunch on this idea, the changes in the fuel source, the ocean temperature and heat content, are much greater than any compensating changes, such as a warming and drying mid-level in the atmosphere that it hasn't been observed. There's really no way of detecting that yet. What do you think?
Yeah, I think I would say the jury's still out a bit on what impact the shipping regulations of change of 2020 have. So just for a little bit of a background on that, and I don't know all the details, but this is kind of the big picture. Ships were required to emit fewer aerosols starting in 2020, and that's great. We don't want to be spewing all that junk into the atmosphere, so fantastic. A consequence of that, though, is it turns out cloud droplets love to form on those little aerosols that the ships were spewing out. And those bright white reflective clouds are now not as present as they were. And it's not necessarily something that happens all at once. So, this is 4 years ago. So could that be partially responsible for that jump that we saw about a year ago, a little more than a year ago? I don't know. That also does not fit into that jump effect that we saw, because exactly like you were saying, generally we have a climate change signal, and the oceans are warming. There's no doubt about that, and there's a trend. That doesn't mean every year is consistently warmer than the last. There's wiggles, there's bumps, fine, but the trend overall is definitely upward. But the years generally behave like each other. So that it's gradually nudging upward with the bumps and wiggles. And then May, June of 2023 came around, and it was just like, we just fast forwarded 50 years or something, and it hasn't gone back down to what it was before that yet. So yeah, there's more to it than the shipping regulation change. There's more to it than climate change. I unfortunately don't have the answer to this either. I haven't heard anyone who does, but it's really an amazing thing to be watching happen.
Brian, what's the geography on this record warm water? Is this the main development region also getting into the Western Caribbean and Gulf? Or is this the entire Atlantic basin? I mean, what are we looking at here?
Yeah, it's the whole North Atlantic. I mean, and when I say whole North Atlantic, I mean like from the equator up to Greenland. Basically all had this jump effect in the spring of 2023, and it hasn't returned back to pre-time values, pre that value. In terms of sea surface temperature and ocean heat content in the tropical Atlantic, where our interests in the hurricane world are, we don't really see this in the Gulf of Mexico so much. That's kind of been relatively normal. But we do see it in the main development region, which spans from the coast of Central America way over to the west coast of Africa. And it's that thin strip through the tropics that we call the main development region, because that's where the large majority of major hurricanes form. So it's comprised of the western part of the main development region is the Caribbean, and then you have like what we generally call like the tropical East Atlantic is the eastern 2/3 of that or so.
Brian, we hear people talk about sea surface temperatures, and then we also hear you mention oceanic heat content. What's the difference between the two? Why are both important?
Yeah, the sea surface temperature is pretty easy to understand. It's a pretty intuitive phrase. It is the temperature of the ocean close to the top. And that's generally important for storms, hurricanes that are moving along at a decent speed and aren't really, really strong. Because as hurricanes move over the ocean, they churn it up. They can upwell cooler water from be low if there is any. So that's where the ocean heat content concept comes in, where it's not just the temperature at the ocean. It's kind of an integrated metric from the surface down to a depth. So it's it's a lot more robust. It's harder to change that. And so the ocean heat content across the main development region is just absolutely record breaking. It again looks like it would during the peak of hurricane season, and we're far from that. And so when you have a strong hurricane, like this one, for example, going through the Caribbean, it's very hard for it to even make a dent in the sea surface temperatures because there's no cool water underneath it. So
you're saying you not only have warm water, but you have warm water with depth, is what you're saying, right?
Yeah. So you can have a category 4 and 5 hurricane churning over this ocean, and it's only churning up more warm water.
Yeah, and plus the barrel's moving so fast that just the length in a small storm, the length of time the upwelling's going on is much shorter than on a very large hurricane like Dorian.
Yeah, exactly.
The RI issue, I haven't really been following the other basins that closely, but I sense that the RI has been more frequent also in the Eastern Pacific. I don't know about the other basins. Do you have any knowledge of what's going on with RI in those basins?
I don't remember offhand if there was a paper published, not too long ago, that went through this. It's really a hard nut to crack in other basins because without recon, we have a pretty short period of time over which we have reliable intensity estimates. And if you're looking at trends of rapid intensification and I don't know, I struggle with that because it's a relatively short period of record that's reliable. In the Atlantic, it's certainly more reliable because we have recon, not in the entire Atlantic, but in the west half of it or so. And that absolutely helps. And there are increasing frequencies of rapid intensification.
Right. You might want to, for the viewers that may not have been studying the high-level meteorology over the years, go through what the current thinking is of the various factors that contribute to rapid intensification.
Yeah, so I guess to even start at a little precursor to that. So rapid intensification is just a phrase to describe the high end, the highest end, like the top 5% of intensification rates. So storms can weaken and strengthen, and generally if they weaken, they generally don't. If they intensify, they generally don't intensify rapidly because, like I said, it's defined to be about the top 5% of those rates. So it's really the outlier end of this. And certainly things like a warm ocean help. Hurricanes rely on evaporation from the ocean, from a warm ocean. So the warmer it is, the more evaporation and moisture you have going into the storm. They also, part of what is required for rapid intensification is you need relatively weak vertical wind shear. Not necessarily extremely weak. I mean, you can get rapid intensification even in 10 to 15 knots of shear. It's happened. So I don't know that we're seeing a huge trend in shear across the Atlantic, but we are seeing the oceans warm. And so I think that's really the primary player in what we're seeing in the trends of rapid intensification.
Interesting. What it shows how long it's been since I've played in that realm. There was a lot of thought when I was there that those environmental factors, the shear and the ocean heat, were maybe half of the factors that lead to rapid intensification, and processes in the almost down to the storm scale and the eye wall was the other factors. Is that no longer a part, or is it still a player?
That is still a player. Yeah, it's a much harder player to get at. Rapid intensification is still a challenge. It's a forecasting challenge. I would say we absolutely have more skill at it now. In the past few years, the Hurricane Center has explicitly forecast rapid intensification quite a few times now and been right. That's mind-blowing. I mean, that used to never happen because it is an outlier of a forecast. And generally, they try to play a conservative, safe forecast. I mean, obviously you want to be as accurate as you can, but generally forecasters don't predict outlier events. I mean, it's because it's very easy to be wrong. So to forecast it with confidence and then end up being right is really, really amazing. It speaks to the progress that's been made in the last, even 5 to 10 years.
I would have, if I was somewhat dubious about it. The more I learned about it as the goal in the HFIP process of cracking the code on that, because I was fixated on the inner dynamics of the eye wall. Why I brought that up is exactly what you described. The forecasting of rapid intensification is means that the environmental conditions really are a key role, or it wouldn't catch it at all. But it seems like both the ship's probabilistic forecasting and the improvements in the hurricane scale models also are capturing this, which gives the forecasters the confidence to go with that. Do you know what kind of changes that have gone into those techniques that have led to the improvement?
I think in ships, I'd have to see if they've added any new predictors in that. I don't remember that they did. So that's generally a fairly large scale type things. But I think to get back to what you were saying about the like inner core processes and things like that, that's absolutely still an ingredient. It's just a harder one to explain at a top level, because I don't think anyone totally understands all the reasons or all the processes that go into it. The hurricane scale models are certainly doing a good job of it. I should say for many, many years, they have forecast rapid intensification, but with a lot of false alarms. Reducing the false alarm rate is what's been really great progress.
That is true. Well, Tim, according to our schedule there, you're supposed to tell us all about our sponsors and give my throat and Brian's throat a break while Hal talks about his program.
Ain't those sponsors great? That's what it's all about. We appreciate them making it possible. Fascinating discussion. And we get a bunch of questions coming in over here too about not just RI, but about the record heat content. So I'll ask those in a minute as well. But we do want to thank our sponsors. And first and foremost, we can't say enough about USAA. My goodness, from the time we started doing programs before NTWC, before the Storm Science Network, I mean, years ago, USAA jumped in and said, yes, we agree with what you're doing educationally, not just for meteorologists around the world, but for students, kids. A lot of projects for kids, and USAA jumped on and said, we want to be part of that, and we appreciate that. So thank you to USAA for all they do. We started talking about doing a conference in person, and the South Padre Island Convention and Visitors Bureau said, we want you to do it here, and we want to help you with that. We want to be your partner. So the South Padre Island Convention and Visitors Bureau has been a big part of what we've been doing from the very beginning with the National Tropical Weather Conference here on South Padre Island, where they host us every year. And we'll be back in April of 2025. I can't believe we're talking about 25 already with our conference back at the Marriott Courtyard Hotel. The dates are set first week of April. It's going to be bigger and better. A lot of special things being planned for that right now. So thanks to the SBI CBB for their support on that. Weather Boy, if you don't know about Weather Boy, check them out. Just look for Weather Boy online. Really cool stuff they're doing, but they provide scholarships for college students to come to the National Tropical Weather Conference. All expenses paid for meteorology students from all over the nation. They enter a contest, and we bring a handful of them to the National Tropical Weather Conference and get to interact with guys like Brian and Hal and Bill, and really sit down and have one-on-one conversations with people in the industry, and Weatherboy makes that a possibility. The Weather Company, they're the people that provide a lot of the graphics that you see on television at my television stations around the country. They're a big part of this. And Weather Call, joining in the last couple of years, boy, we appreciate them. The next generation of Weather Call is something special. Severe weather's coming, your phone rings and tells you from the voice of someone you know and love or hate, but the voice of somebody you know saying, hey, there's something coming. So we appreciate Valerie and everybody at Weather Call for being part of this as well. Of course, GeoTrek, Dr. Hal Needham, Hurricane Hal. GeoTrek, you guys have been doing this kind of stuff for a while and you do some fascinating programs, Hal. You interview people all over the place about fascinating things, and you have a way of asking questions that really bring out the best. You really bring out fascinating stuff. What are you up to this week, Hal?
Thanks so much, Tim. With GeoTrek, we're exploring the world to tell these stories about natural disasters and extreme weather not covered by the mainstream media. Check out our podcast. We're interviewing experts in disaster resiliency, forecasting, storm chasing, just to help you understand how to better prepare. We had a podcast that launched yesterday with a very dynamic personality in disaster science. We featured an interview with Leslie Chapman Henderson. She's the president and CEO of FLASH, or the Federal Alliance of Safe Homes. What they're doing with FLASH is they're really passionate about helping homeowners better prepare for the impacts from flood, wind, tornadoes, hail, winter weather, whatever it is, whatever peril threatens your community. They're helping homeowners better prepare. And what I loved about our interview is they're very focused on giving people achievable and affordable actions they can take to better prepare their home. So this hurricane season, as we're watching these potential tracks come to your neighborhood, you don't need to sit there in a passive sense and say, I hope it doesn't hit. There's things you can do to get out ahead of these storms, to empower yourself and to help you prepare your home to be more resilient for these storms if they do come your way. You can check that out on our latest GeoTrek podcast, wherever you listen to podcasts. GeoTrek podcast now ranked as the #1 podcast on the topic of natural disasters, according to FeedSpot. This was podcast episode number 98. It just released yesterday, called Federal Alliance for Safe Homes with Leslie Chapman Henderson. I know she's a dynamic personality. We featured live there in South Padre at the National Tropical Weather Conference. It was the first time she came on our podcast, and boy, did I learn a ton from her. And already we're hearing a lot of positive feedback from our audience.
Awesome. Thanks, Hal. She is a tremendous personality and a great spokesperson for what she's all about. So I can't wait to listen to the podcast. Sounds like
Tim, lastly, if people go to flash.org, they can find an amazing dashboard there where you can actually pull down different perils. If you want to prepare your house for hail, wind, flood, whatever it is, wildfire, you can actually dig into those perils, and there's all kinds of action items that you can take to empower yourself and prepare your home.
Great website. And for as storms come in, whether it's hurricanes or anything else, good information. Thank you, Hal. I appreciate that. Can't wait to listen to that episode. We appreciate that. Well, let's get back to Brian. I've questions coming in from online. Let me ask you a couple of them, and then we'll let Bill and Hal jump back in. Casper's asking about the Hunga Tonga eruption and whether that's had an impact on the rapid rise in Atlantic sea surface temperatures. Have you seen any correlation there?
Yeah, I've heard that there, I guess it's complicated. I guess I wouldn't totally rule out some influence, but I don't think that's the ticket. It's another kind of thing that we're seeing these changes come about rather abruptly and at a time that doesn't really match things. And it could be a slice of the pie, but my hunch is it's a relatively small slice.
The Hunga Tonga, of course, in the South Pacific and a couple of years ago. Have you seen any kind of an anomalous jump like this historically? I mean, we're talking about what happened, last year, the big jump. Have we seen anything like that years ago that you've seen? Anything close?
No. Usually, historically, when we, there can be little jumps, and then your record-breaking for some period of time, maybe weeks or a month or something like that. And then it kind of relaxes back down to be in the crowd. We've never had something like this where there's a jump and you never relax back down. I should say never. We're not finished with it yet, but it's been 14 months or so, and it still is not relaxing back down to anything. It's still very, very anomalous and not looking like the pre-2023 years.
Is there, we of course, we're focused on the Atlantic Basin because of the hurricane season and everything here. Is there any kind of an offsetting drop anywhere on the planet that you know of? Is everybody heating up, or is this just just the Atlantic Basin that's seeing this?
Yeah, I'll take a look at something real quick just to make sure I'm current with this. But the world as a whole has been also fairly anomalously warm since spring of last year. So it's not just the tropical Atlantic. And, one of the other components, one of the other pie slices, I guess, is El Nino, which, again, I hesitate to give too much credit to that for causing this, because we started to see these warm anomalies creep up really before El Nino was in place. It was just coming in early last year, and it certainly wasn't strong yet. So, El Nino does have a large fingerprint on the world when it's strong, but we started seeing these changes before El Nino was really in place, and we're still seeing them, and El Nino is no longer in place.
Right.
Bill's got something. Yeah.
Popped up the global anomaly, and it's mostly warm. The cooling, you see the La Nina developing along the equator in the Pacific, and some areas have cooled in the eastern North Atlantic, but by and large, it's warmer than normal.
Wow.
Yeah, and that cold tongue that you see sticking off of the west coast of South America, that is the onset of La Nina.
Yeah.
All right, jump back in there, Bill. Those are our online questions for now. Go ahead.
Yeah, the study I read on the Tonga actually quantified the impact, and you're correct in at least from that author's point of view, that the effects would be somewhat not anywhere close to explaining the amount of heating that's gone on strictly from a radiative process from all the moisture jammed up in the stratosphere and spreading around. But interesting topic on that regard.
Yeah.
How far back does accurate sea surface temperatures go for the purposes of comparing hurricane seasons?
Well, so we generally, we have for sure back to the early 1980s is pretty much a self-consistent daily record. So for sure that long, we're at 40 some years there. We have probably with less confidence back to the mid 1800s. So, but even if we don't go back that far, just going back to the 1981-ish time frame, that's a pretty long time to be looking at the same patch of ocean and being very certain that you're looking at it the same way. And it's a great way to see just a warming trend, because it absolutely shows up. Again, it's a general trend with wiggles and bumps, and some years are record-breaking at times and record-breaking cool at times, but the trend is up. So at this point, it's virtually impossible to set a record cold, a record low. And it becomes increasingly easy to set record highs. But what started in the spring of 23 is just off the charts.
Yeah, I was thinking in terms of the 1933 season, I would love to see what the sea surface temperatures were like then. I mean, my assumption going in is they had to be warmer than normal to get that much activity.
Yeah. So we could look at that. I don't have that at the moment's notice right now, but it's something I could look at, and we can revisit that offline. But to at least see what the North Atlantic sea surface temperature looked like in 33 compared to what it is now. Yeah, that's a great point.
Yeah. Uh, the radar data that you put on your tropical Atlantic headquarters site there, are there any new and improved versions planned for the Caribbean basin that you know of?
Nothing new. I mean, I basically just rely on radar data and images that are out there. And so, for example, right now, it'd be great to have a radar loop out of Jamaica, but their radar has been down for years. And we're at the mercy of that. So I mean, sometimes the types of radar images and what's available to the public evolve, and I try to keep up with that. But the one out of Barbados that we just had a few days ago, two days ago, I guess now. That one's changed a bit. So I end up having to just grab a form of the data that they have and create my own plots, and then can create a loop of those. But yeah, it involves a lot of scripts that are running every few minutes, and that tropical cyclone archive that I've got of radar loops has, at this point, I would guess in the 520 or so radar loops of tropical cyclones from 30 countries or so. So it has become quite a beast.
It's very useful. I occasionally get requests for some insight on storms that aren't in our basin, and being able to go over your site and grab those. A picture's worth 1,000 words when you're trying to explain something to someone.
Yeah. It's certainly not a complete archive. It's as complete as either I could do, or if there was a radar there.
Yeah. I haven't heard. I also haven't heard of any new initiatives. The current suite of radars that cover, like you said, Grand Cayman, Barbados, and the Northeast Caribbean, also coupled with Puerto Rico, give a pretty good coverage. The storm has to be pretty far, right in the middle of the Caribbean, to be out of range now of a radar.
Yeah.
15 years ago, you had zero of modern radars down there, the Doppler radars.
Yeah, we got pretty good coverage. In fact, yesterday, Barrow was about halfway between the radar in Curacao and Puerto Rico. So you could, from one radar, you could see one end of the eye wall, and from the other radar, you could see the other side of the eye wall.
Yeah, and it was loud and clear. It shows you how tall the Y wall had gotten.
Yeah.
Hal, you're smiling. You must have a question.
I have a question for both Brian and Bill here, for you guys both professionally and personally. What do you think the social impacts are of rapid intensification? So professionally, we know a lot of the language for coastal communities say 96 hours before landfall, we do this, 72 hours before landfall, we do this. What if we don't have those lead times professionally? And then also for you guys personally, Brian, you're there in Miami-Dade County. Bill, you're living along the Houston-Galveston corridor, both very densely populated areas vulnerable to hurricanes. How could this impact you, your friends, your community as well, if a storm like this rapidly were to intensify before making landfall where you live?
Brian, go first.
All right. It's a very scary thing. I guess that would be I think anytime you have rapid intensification near land. I mean, when it's over the ocean, it's interesting. Great. When it's happening up to land and just before making landfall, it's extremely scary. We don't always forecast it well. I mean, one of the most horrifying examples of rapid intensification up to landfall was just last year in the East Pacific with Hurricane Otis just exploded. I mean, it's really a worst case extreme rapid intensification. And that's a storm that I think I like to frame as like, that it didn't have a lot of aircraft reconnaissance. So that's one thing that would be not quite the same as if it happened in the Atlantic, but you have the same hurricane models running on that. You have the same people working at the National Hurricane Center making forecasts for Otis as you would for something in the Atlantic. Same models, same people. Could an Otis-like thing happen in the Atlantic, knowing that we would have had more history of aircraft reconnaissance going into it? Yeah, I don't know. I mean, obviously the type of intensification could, but would we have known about it?
Yeah, I'll give you an example. Maria in Dominica.
Yes.
It was forecast to be a Cat 2, and it was on the cusp of a 5 when it hit there.
Yeah.
The social impacts of these big urban areas. Miami has a don't go far evacuation plan, which makes a lot of sense because there's the way Florida sits, you're competing with everyone else up and down the coast if you get on the freeways. The Texas coast is pretty, I mean, they encourage people to stay, but those that know the building codes know the folly of some of that. There's not enough, there's over 1 million people in the evacuation zones around Houston. There's not enough storm-ready buildings to put people in. The other part of the equation that people don't talk about too much, I mean, they talk about evacuation, have all these plans, good car and all that stuff, a place to go, a place for your pets. Probably a third of the people that you want to move can't afford that. And how you've got in Galveston, parts of Galveston are very low income. In the county, we've got the San Leon Bay Cliff areas that are probably about 10 feet above sea level, and that's mostly lower middle class income. And it's not the financial hurdle to get over is enough for people to say, I can't afford to go, and they try to roll the dice. Me personally, I can afford it, and I'm up 30 feet, so I do what I can. I've hardened the house a bit. I've added a fortified roof, courtesy of what I learned through Flash, and while not Miami-Dade code, it's certainly I think it'll stay for most hurricanes. Once I pay off that roof, maybe I'll go with a whole house generator for next year. But that's not something that the majority of people can do. And I hate it when I see these recommendations. You should do this, because a lot of people are going to say, you got to be kidding me. It's a $10,000 to $15,000 investment when you do that. And we learned in Rita, our roads can't handle 2 million people at the same time. That kills more people than the storm. So it's the 96-hour thing and the rapid intensification is a very real problem. If the inner core part of the forecast is one of the drivers, how far out in time are we ever going to be able to forecast storm scale dynamics? It's almost
some of the dialogue I hear on our workshops and podcasting is that you don't necessarily have to evacuate 300 miles. Just get out of that surge zone. Yeah. And I've been at recent workshops where we talk about public shelters, but in my understanding, a lot of it's used in the conversation of, okay, people that don't have cars that are going to be on buses, they go to public shelters. Like on social media, for example, and at these workshops, I rarely ever hear people with vehicles talk about public shelters. They're usually thinking go far inland to hotels, things like that. I mean, are there, like, and this is kind of an open-ended question for both you guys, but where you live, is there talk about public shelters that aren't that far, that get you 15 miles inland instead of 200 miles, that are accessible if there's a rapid intensification and just it's a time issue? Maybe people have the money to leave, but there's not the capacity. What do you guys hear in Houston, Galveston, and in Miami as far as shelters that just are there for people that just need to get out of the surge zone?
I haven't heard much recently. I think Florida probably has a little better shape. Monroe County, the Keys actually have designated buildings. And there's always a debate whether to advertise those in advance so that it'll keep people from going because they know they have a place to go, but I'm not sure that's realistic. When I was still working this area here, the liability issue, no one was going to open a shelter and take the liability if the building collapses from the wind. Have they changed on that? I don't know. I'm not in the evacuation sphere all that much these days. Brian?
Yeah, and down here, the the last time that it really came into play was 2017, leading up to Hurricane Irma. And I certainly remember hearing about the evacuation shelters, and they are local. They were actually in town, and because really, yeah, they're the point here is to get out of the surge zones. So they don't evacuate based on wind. And so there are local shelters, and people use them. We had pretty well a lot of widespread evacuations from that storm because of the track going right up the spine of Florida. That was the forecast. It ended up moving a little tiny bit further west than that. And so the southeast coast of Florida fared quite well during that, but that was not the outlook even 1 to 2 days out. And those few miles made a gigantic difference in outcome. So just wanted to say too, back on the rapid intensification aspect of this, is if you have a tropical storm out there and it's forecast to become a Category 1, or let's just say like an upper end type of Category 1 hurricane when it reaches you, and then 1.5 days or so before that, it just starts to rapidly intensify. It's just impossible. You can't possibly evacuate a big city like Miami or Houston in a day. It's no matter what you want, it can't be done. So it's really a challenging problem.
Yeah, they got a lot of blowback in Harris County for not evacuating for the rains of Harvey, and the feedback they gave back is, which ones do you tell to evacuate?
Yeah.
Even 24 hours in advance of the onset, you don't know which bayous are going to go into extreme flooding. They're tiny basins, and where are you going to put them anyway?
Yeah.
They're safer in their homes going to the upper floors than they are. I mean, if they're in really high flood risk areas, yeah, maybe you can have some kind of plan to get them out, but it's almost an individual basis rather than an official basis.
Do either of you guys know this statistic? I heard of the 4 landfalling Cat 5 hurricanes in the U.S. You don't have to go that many days out, and they were like tropical storms. Do either of you guys know that statistic? I was shocked when I heard it.
Yeah. I have a map of those 4, and the answer is 3 days. So all 4 Category 5 hurricanes that hit the continental U.S., which was the 1935 Labor Day, Camille, Andrew, and Michael, all 4 of them were tropical storms 3 days before they hit.
That's a tremendous statistic when you think, right? And I mean, when you just picture that's not that long into the future, and you have a Cat 5 on your doorstep.
Yeah, that's scary.
And Harvey was a tropical storm 48 hours before landfall as a Cat 4. And the main difference for a lot of places between a Cat 4 and a Cat 5 is how you rearrange the debris.
Yeah.
We got a good question coming from online, guys, and let me go back to rapid intensification in this day of amazing satellite imagery that's coming in now. Casper was looking at stuff, and he said you could see all these little mesovortices in the eye of Beryl out there that looked like they tried to get incorporated into the surface circulation right before RI really got going. Do you see any correlation with that? All those little mesovortices in that eye that may be indicative of something starting to ramp up?
The little swirls and vortices that we see in the eye, they're very common. I mean, anytime you have a clear eye in a hurricane, they'll be there. What we generally think of as a mesovortex that has an influence on storm structure and intensity, they're generally riding right along or in the eye wall. So when the eye wall structure itself is not a perfect circle, but it actually breaks down and has these little mesovortices in it. It's usually, of course, there aren't any hard rules in nature, but usually the sign that it's weakening a little bit, but reorganizing to later re-intensify. So it's a little bit of, it's just rearranging a little bit. But those swirls that we see, those really low cloud swirls that look really amazing, they're there in every clear eye hurricane.
This has been a fascinating discussion. We're running up against the top of the clock here, top of the hour here. So I want to give you a chance, Brian, last opportunity here just to promote your website, information that's out there. What's out there if people want to go find you? Where do they go?
Oh, yeah. So the website is bmcnoldy.earth.miami.edu. And then there's a bunch of things on there, some of which are the real-time products like these radar loops and other ocean heat content products and sea surface temperature maps and all sorts of things. And then just other historical tidbits about things that I've done and not as fun as the real-time stuff.
If we Google you, we'll find a lot of articles that have been written just in the last couple of weeks about rapid intensification, about the sea surface content. I remember back to when I don't know if you knew Nicholas Koch, and I know Bill, you did, Dr. Koch out of New York. When you started talking about the sea surface temperatures being so hot, and he would talk about impact of a hurricane on New York, and he'd say people called him Dr. Doom. And then when after Hurricane Sandy hit, they said, what do they call you now? They said, they call me often. And I think it's the same kind of thing. You talk about these record-setting heat content. A year ago, it's like, oh, this is just Dr. Doom out there telling us how bad it is. Now they're calling you often.
Yes.
So, Hal, final thoughts as we wrap this up?
Oh, Brian, just amazing insights. Keep up the great work. I love that you have so much data and resources available online, and you're always a great resource. I know for myself and many of our colleagues, we've reached out to you at different times when there are actually active storms out there, and you're always so responsive. So keep up the great work. Thank you so much for coming on the show and sharing your insights with us today.
Oh, my pleasure, Hal. I really appreciate it.
Bill?
Yeah, I'm beginning to think I should have executed my somewhat humorous evacuation plan, which is on June 1st, drive to New Mexico, come back on November 1st. Al and Brian, as always, it was a great discussion. I like the interplay we had there and learned a lot from it.
We appreciate it. And one last question from the web. They just want to know if you can put your 1933 data on your social media, Brian, the data from 33, so people can...
I will write a note to do that right now. 1933. Okay.
Put it on your social media so folks
can... SSTs, yes.
There you go. Gentlemen, thank you. Fascinating discussion today, as always. What a great program this has been, week in and week out. NTWC Plus putting out some fun stuff, and we appreciate, Brian, you taking time to be with us today. I want to thank all our sponsors who make this a possibility. USAA, the South Padre Island Convention and Visitors Bureau, of course, the Weather Company, Weather Boy, Weather Call, all folks that help make NTWC Plus a possibility. We remind you, we will be live in person April of 2025 at the Marriott Courtyard Hotel on South Padre Island. Watch soon for registration information will be coming up for that. Maybe not this week or next week, but probably in the fall sometime once we see what this hurricane season ends up looking like. So next week, we'll be back with another great program Wednesday morning, 10 a.m. Central. Until then, have a great week. Thanks again, everybody. We'll see you.
Thanks for watching NTWC Live. You can also listen to our podcast, which is Hurricane Center, and it's available for Spotify and Apple. Don't forget, you can also watch us on Roku and at hurricanecenterlive.com. Next week, we'll have Brian Lowry. Thank you so much for being with us. Okay, we are good. Close is done, and that was a great show, everybody.
Everybody.
All right. Well, you guys say